To the learning of computer networks and security. We are going to start with the module 5, that is multimedia networking. Let's see now the streaming stored video application in detail. So we had already seen three types: streaming stored video, then streaming live video, then conversational video and audio. So out of that, one of the applications, streaming stored video, we'll see in detail. We have three categories in streaming stored video audio. So the first category is UDP streaming. The second category is HTTP streaming technique, and the third and last streaming technique is adaptive HTTP streaming technique. So we'll see in this each of this streaming technique in detail. So we'll start with the UDP streaming technique. So remember, all three are streaming stored video audio type of application. So we'll see the first type, UDP streaming technique. So we'll just analyze the streaming technique over here. Here we have a graph. You can just see along x-axis we have plotted the time variation, and along the y-axis we have the video streaming, that is the play out sequence, cumulative data. We'll just see that graph. Okay, so you can just see here along x-axis the timing constraint of the server is shown. So what is it? See, like how we have in streaming stored video, client is basically requesting for a video and the request is sent to the remote server. For example, if I'm accessing, if I want to watch a YouTube video, I will just click on to the video link that is available on the screen. So the link, when I click, the moment I click on the link, the request will be redirected to the remote server here. So the remote server is nothing but the YouTube server. So now the server will send the requested video file to the remote client. So the server first should search whether the video is available in its database, and accordingly the video is searched and the file is sent to the client. Now see how the file is sent. So the file is sent actually byte by byte, and as you all can see, all the bytes are not sent at once. It is sent at different instant of time. And you can see the sending rate of the server, it is 30 frames per second. You can just see it is 30 frames per second. For every 1 second, 30 frames are sent. And you can just see the timeout here. You can just see the timing here shown. Okay, how the video is sent. At time, say T0, at time say T0, the first frame is sent. Okay, maybe the first frame is sent, and after certain amount of time the next frame is sent, and the next frame is sent. So likewise it goes on at every instant of time. You can see the frames are sent at every instant of time, and you can see here the variation in the timing. Say, let me call it as delta. It is fixed here. It's constant here, this delta variation. So or you can say the gap between the every frame is constant. And let me take it as delta. So T1 plus delta, it indicates the timing of the next frame that is sent. So everywhere this delta is constant. You can just see here, and the video is sent. And you can see here the third one indicates the play out period. So once the video is received here at the client, so how it is received at the client, that is at every instant of time, frame by frame, it is received here at the client side. And here the client as and when it is received, the client will start his playout, or the client starts consuming the video, or his playout begins. And again, how was it, how the playout is, the rate at which the client is playing the video is also for every 1 second 30 frames, so 30 frames per second. And you can see here how is watching. So at time t0 here he started his playout, and again at time t1 again this playout continues without any delay. It also, the client is able to watch or play the video. And this you can see here, this is an ideal playout, and this is possible only if there is no delay at all, there is no network congestion at all. Okay, so this is something like the video sending rate and the client's receiving rate, as well as the client's playout time or playout rate is synchronized, it's matching. So here there is no delay at all, and you call it as idealized or the perfect playout of video. So you call this as streaming. So why this you call it as streaming? So here, whenever the video is sent by the server, the client is actually receiving that bytes first. So once the bytes are, or once the frames are received at the client side, client is immediately not playing that, right? So as in when the frames are received, or as in when the bytes or video file is received by the client, first he is storing those frames or bytes in his buffer, in his client's buffer. So once certain portion of the buffer is filled up, or once certain bytes or frames are received at the client side, okay, so after certain portion is filled up, then only the client will begin his playout, right? So initially, as and when the bytes are received, the client is not going to start his playout. So after certain amount of bytes are consumed, or once it is stored, once he has reserve in his buffer, then only he is going to begin his playout. The client is going to begin his playout, so that there is no delay experienced at the client server. So you can just see playout is started only after the early part of the video is reserved here, or it is stored in the buffer. Okay. Okay, so we'll just see now what are the challenges in this streaming stored video. So, or when exactly the client's playout disturbs there, or when exactly client experiences delay. Okay, so whenever there is a jitter, or whenever there is varying bandwidth between client and server, or whenever the sending rate and the receiving rate mismatches, you can just see here the delay is experienced at the client side. And you also have one more feature available at the client side. Like all of you might have seen in YouTube application, there is interactivity between client and server. Like client is or the user is given with the pause button, fast forward button, rewind, jump button, wherein you can move the slide bar wherever you want, right? So this interactivity is also possible, right? So this is also one of the challenge that has to be faced. Okay, and here definitely whenever there is congestion, most of the packets that is sent from the server to the client might be lost, and because of which server might have to retransmit few parts of the video. Okay, so these are all the challenges faced in streaming stored video. Now let's see how exactly the client watches the video whenever there is congestion in the network, or whenever such challenges the client has to face, how exactly the playout is happening at the client side. We'll just see that. Okay, you can just see now the first graph, as I already said, in the perfect or idealized situation, how exactly is the playout. Okay, so this first graph, what you can see is the server sending rate. How exactly the server is sending? You can just see he is sending frame by frame or byte by byte. The video is sent, and you can see the sending rate is constant. At time t0, maybe I'll just take this as at time t0, the first frame or the first set of byte is sent, and after certain after some time, that is after delta time, that is after you can say this, you can call this as at time t1, which is equal to t0 plus delta, you can see the next frame is sent. This horizontal thing is the time taken there, the gap between the first frame and the first frame, next frame and the previous frame. This is the gap between the next frame and previous frame. Okay, so everywhere that gap is constant, and this is actually the server's constant rate of transmission, okay, from the server side. And now whenever you can just see here, the client is receiving the bytes. The second graph, what you can see here, this black graph, is client's receiving rate. Okay, client's receiving rate. So how exactly the client is receiving the data or the bytes? So at time t0, say the first frame or the first set of bytes is received at the client side. And you can see here this horizontal gap. This horizontal gap. What is this horizontal gap? This is actually the delay that the client is experiencing in receiving the next byte of data. So at time t1, which is after certain gap, he is receiving the next set of byte or the next frame. And why this is happening? Because of the varying congestion or the varying bandwidth between client and server. So you can see at time t1, now after a long gap, he has received the next byte of data or the next frame what the server had sent. And now you can see at time t3, the next frame is received. At time t4, fourth frame is received. At time t5, the next frame is received. And you can see here there is very little gap when he is receiving the next frame. This gap is very smaller, right? And maybe you can say that the small gap indicates the low congestion in the network. There might be less congestion in the network, because of which this gap is very small. And you can experience, the user is experiencing, the client is experiencing long gap here because the congestion might be very much high here, right? And again you can see here the gap is high. Why? Because the congestion might be increasing here. Again here the congestion might be there, because of which the gap is more. So this varying reception rate at the client side is the major reason, and you can say the major cause behind that is the varying network delay. Okay, so that is between server and client. And now you can see after certain amount of bytes or frames are received at the client side, now the client has built up reserve here at the client side. You can say the buffer what the client is maintaining is filled up by these received bytes. So once you have enough reserve in the client's buffer, the client can start his play out. This orange or this yellow color graph, what you can see is the play out what the client is you can say the client's watching rate or the play out rate here. How exactly is client playing? See, you can see after certain amount is reserved or it is stored in the buffer, the client begins his play out. And how is his play out? Again, at time t0, he is able to now play the first byte whatever he had received, first set of bytes what he had received, or you can say the first frame what he has received, he can watch that, he can play that. And whatever he is doing, he is just emptying that buffer, whatever he had stored that bytes, he is just consuming it, or he is emptying that. Okay, that is called as play out. And the next set of byte whatever he had stored in the buffer, that is playing. The next frame he is playing, and the next frame is playing. So whatever he is able to play here, that is all because of the buffer, or that is all because of the frames that is already stored in the buffer. So that particular contents he is just playing without any delay. And you can just see here this play out rate also is constant. There is no much delay there. Okay, so everywhere he is trying to, throughout he is trying to play with the constant rate. And this graph, the third graph, is matching with the server sending rate, right? So since this was also constant, here the client's play out rate is also constant, his expense rate, and that is all happening because of this reserve what the client has built before play out. Okay, so I hope this is clear. Okay, we have now HTTP type of streaming. Whatever we have, the HTTP type of streaming in the streaming stored video. Okay, so what is that HTTP type of streaming? We'll just see here. So the previous one, whatever we have seen, is the UDP type of streaming. So in UDP streaming, we have seen that graph, how exactly the delay is experienced by the client and all that, right? So we'll just see now this how streaming stored video is done over HTTP streaming. Okay, right. So what is this HTTP? As you all know, this is an application layer protocol, and application layer protocol is used for sending the request, HTTP request, from the client side, and the server will again send the response back, or here the response is actually the video file what the server is sending in the form of HTTP response, right? So here we'll just see this technique. Okay, so this is very clear now. See, first actually, okay, we'll start from the client side. First actually, client will be sending the request. How is the request sent? It is in the form of HTTP request what the client is sending. Or I'll give you a live example. Suppose if a client is visiting the YouTube site. Okay, so there he is given with the list of videos. So out of those list of videos, what the client is doing, he is simply clicking on a particular link. Okay, so on a link he is simply clicking, and the moment he clicks on a particular link of video, his request is redirected to the remote YouTube server. So here is our remote YouTube server. Now server is getting the request. So all that the server has to do is search for the requested video file in his database, and if the video is available, see, you can see here, this is a video file what the server has searched, and that video file whatever is available within the server's database. So now that file has to be sent to this particular requested client. So now you can see that video file is not sent at once, entire video file is not sent, but byte by byte that video file is sent. So first set of frames is sent, you can see. So directly it is not sent. So what the server is maintaining, you can see at the server side, he has something called as a send buffer. So server has maintained a send buffer. So in this send buffer, you call it as TCP send buffer. Why? Because it is the TCP communication transport layer protocol. TCP transport layer protocol is used for sending the data. So TCP communication is happening. It is happening along three-way handshake. Okay, so three-way handshaking mechanism is happening here. So TCP send buffer is maintained at the server side. So initially this send buffer is filled with the frames or bytes that is pertaining to the video file what the client has requested. So those bytes are first filled inside this TCP send buffer. So once this buffer is filled up, now this is ready. Now it is ready. Now it is the time to send the requested bytes to the client side. And you can see how the bytes are transferred over the TCP connection. So packet by packet, or bytes by byte, frames by frames also you can call, it is sent to the remote client. Now how the client is receiving the data? So at the client end, actually we have two buffers maintained. One you call it as TCP receive buffer. So what is this TCP receive buffer? Initially all the packets or all the bytes that is received, first it is stored inside the receive buffer. And you can just see here, it is the reserve that is built at the client side. And you can see here, the client is not starting his play out until some reserve is built here at the client side. So until some reserve is built at the client side, our client is not going to start his play out. Or in other words, here the client's TCP receive buffer is filled up, half of the portion, and once this is filled, now it is the application buffer, it is the TCP application buffer, now the second buffer that is maintained at the client side. So at the application buffer, now these bytes are consumed, or you can say these bytes are now redirected to the TCP application buffer. Okay, so once this TCP application buffer is getting filled up, once it is getting filled up, okay, so you can just see here, this application buffer is the one which is actually directly accessible to the user. Okay, it is the directly accessible to the user, and you can just see here at the application buffer side, again it is some portion of the bytes should be, definitely it is filled up. Whatever was available in the receive buffer, that is pushed on to the application buffer side, and again here once it is filled here to some level, to some level. Now it is ready for the user to consume. So user now can clearly start his play out, begin his play out, or he can start consuming these bytes without any problem, without any glitches. He is able to watch the video, and definitely he has not started once. He couldn't start his play out once this application buffer is empty. He cannot start his play out. He couldn't start, right? Only after this application buffer gets filled with up to some level, then only he has started his play out. So he's able to watch all these frames, all these bytes without any glitches, without any disturbance, because already he has a reserve, right? So by the time he's consuming these bytes, by the time he's emptying these bytes, actually this receive buffer can send the next set of bytes to the application buffer, right? Whenever the playout is happening, the next set of bytes can be pushed from the receive buffer to the application buffer, so that now the next set of reserve is ready at the application buffer. So once the user finishes the first set of bytes, once he finishes playing the first set of bytes, now the next set of bytes is ready for him. It is already built in his reserve, it's ready for him, and now he can continue watching the next set of byte without any disturbance, without any glitches, right? So this is actually the streaming concept. This is actually what is happening whenever we try to watch any videos, okay? And remember here, whenever the user is trying to play, first he has to go with this decompression technique. Why? Because at the server side, the data whatever is sent is in the compressed format, because more bandwidth it will take. All videos will take more bandwidth. So whenever the server is sending, he's first compressing the data and video file, and he's sending. And here at the client side, upon receiving, when the user is beginning his play out, he'll have to decompress it first, and then he can start watching or start displaying the contents on the screen. Okay, so this is what is happening in over HTTP streaming technique. I hope this concept is clear. We can now analyze little more on client side buffering. Okay, what the buffering takes place, whatever the buffering takes place at the client side, little bit more analysis. Let's do it over here. Yes, so here we have the server which is actually compressing the video file and sending over the internet, and it's all happening here, the congestion here in the network, it's all the congestion that is happening here in the network. Okay, let's now concentrate on the sending rate and the receiving rate. Okay, so now the server is sending the video file at the rate X here. So what is that? You can also call that as the filling rate. Okay, so here once the client is receiving the bytes, okay, you can just see here receiving the bytes. You can just see here, this is the client side buffer where you have two portions in the buffer. So this portion you can call it as this first portion you can call it as receive buffer, and this next portion you can call it as client's application buffer. Okay, receive buffer and application buffer. You can now see once the bytes are sent, first this portion should be filled, which is that portion receive buffer should be filled, and from the receive buffer it has to be moved on to the application buffer. And here in the application buffer, when it is empty, you cannot watch anything. This should be filled, certain portion should be filled, then only you can watch the video. Let us call this watching rate or playout rate as R, or let me call this as depletion rate, which is R. So you can see the application buffer space is Q, and this entire receive buffer what you have, entire buffer size is B, and this receive buffer of client, this is the first portion, receive buffer of the client is indicated by B minus Q. B minus Q. First B minus Q gets filled up. B minus Q gets filled up, and then this Q portion, Q bits should be filled up. So there should be certain amount of Q bits in order to have the depletion or consumption of the video. So depletion rate, let me take it as R. So this rate, consuming rate R, is totally dependent upon this filling rate. So let's compare now this X with R. What if this filling rate is less than the consumption rate? What is going to happen? Let's analyze this. Suppose I am filling the bytes with the slower rate. Say slower rate in the sense, let me take the rate as 10 bytes for every 1 second, 10 bytes of video is getting filled up here in the buffer. The depletion rate, let me take it as 20. So what is that? For every 1 second, 20 bytes are getting displayed on the screen, or 20 bytes are getting emptied out of this let me take it as bits only. 10 bits per second, and here it is 20 bits per second. So here out of this qubits, suppose here 20 bits for every 1 second it is getting consumed. So what is going to happen there? Filling rate is very slow, but consumption rate is very high. So very soon your qubit is going to be empty. Very soon your application buffer will get emptied, right? So because of this very high consumption rate, since there are high chances of getting this buffer, this buffer getting emptied. Okay, so because of that, our user may experience high delay or disturbance there in playout. Why? Because by the time the next bytes, there is no time for the next bytes to get next byte from the receive buffer to get filled here in the application buffer. So there is very less time to push these bytes, or there is very less time for the bytes to get filled up here in the application buffer side. Why? Because the only reason is this consumption rate is higher. So you call this as there is no chance of buffer getting filled up. Buffer overloaded or buffer filled status you will never get there, right? So this, because of this, actually the delay will be higher. User will have more of glitches there. Freezing of the video takes place here, right? So what if there is X filling rate higher than the depletion rate? If this is 20 opposite, and if this consumption rate, suppose if it is 10, what is going to happen? Very soon your application buffer gets filled up. Very soon your application buffer gets filled up, and since the user is consuming the bytes or playing the bytes very slowly, 10 bytes for every 1 second, in that case, very soon your bytes gets filled up here in the application buffer, from the receive buffer to application buffer, right? So because of this, what is going to happen there? Very soon buffer gets filled up, overloaded, right? And once your application buffer gets filled up, what is going to happen there? Definitely your the back pressure creates. Once the application buffer gets filled up, back pressure creates, and this receive buffer what you have here, that also gets slowly filled up, right? Since your filling rate is higher, your this receive buffer also gets filled up very soon. And what if this entire buffer gets filled up? It's totally full. What happens in that case? The back pressure creates here at the server side, and definitely when the back pressure creates at the server side, your server side also have something called as send buffer maintained. The send buffer also will get filled up very soon, and once this send buffer gets filled up, there is no option for the server to send further bytes, right? So there is no option for the server to send the next set of bytes. So server has to stop sending the bytes in this case, right? And when this situation arises, can you guess there? So this situation especially arises when the user either stops playing the video, stops watching the video, or if the client pauses the video. So pausing means what? Temporarily he is stopping the play out, or if the filling rate is very much higher than the consumption rate or depletion rate. Okay, so three cases. One, either client stops playing, or whether he pauses playing, or this is the case if the filling rate is very much higher than the depletion rate. In that case, back pressure is created. Okay, so this type of analysis you will have to do for the client side buffering. Remember, the without any glitches, without any disturbance, if the client has to play the video, his depletion rate should be depletion rate should be greater than the filling rate. Okay, and there is because of this, there will be no case of or the no chance of buffer getting you can say filled up, right? Buffer will not be filled up, but without any glitches is able to watch the video.